Hi everyone, I'm Chris Saxon, part of Stephen Feuerstein's Oracle Developer Advocate team and part of the traditional answer team for AskTOM. So I'm really excited to be here to help answer your SQL questions. These are our office hours sessions where you can come along, ask us what you want. Each session usually has a theme where we cover a particular topic. This week, we're going to be looking at distributed queries, so queries across database links, how you can tune and optimize those. As always, if you've got questions, just stick them in chat. I'll keep half an eye on that as we go along. And if there's any other ideas or topics or things you'd like to discuss in future sessions, please let us know. Okay, so that's the intro. Let me jump back into the slides and share that, and let's get going. So this relates to a question that came in on AskTOM a few days ago. So person had a problem with query across a database link. So they had two parts to it like this. So they had a really big table and they wanted to group that information up. So aggregate it down to just a handful of rows, presumably, because as you can see, they're then joining it to a small table, which also goes across the database link. And they're looking at what they could do to improve the performance, make it faster. And they were specifically kind of asking about this kind of materialized hint. So those of you who don't know, what this hint does, it tells the database to pre-compute the results in this subquery and kind of store the results in an on-the-fly temporary table and then use them later. And they were a bit concerned that this wasn't working properly or didn't seem to always be giving them the performance that they wanted to. So they're saying, well, what can we do about it? Now, there's lots of techniques or lots of things you can do when it comes to tuning queries over database links. But before we kind of get into those, I just wanted to say about the materialized hint. So this is an undocumented hint. It's kind of well understood what it does, but there is no documentation officially saying exactly what it does. That means its behavior is subject to change without warning, without notice. So I'm not going to talk about that at all, other than here in the question. There's various blogs and so on discussing it if you want to know more about it, but bear in mind that you're taking a risk that if you use it now, behavior for that might change in the future. So be aware of that. Oh, so excuse me. But what I wanted to do is just take a more general approach to tuning queries over database links, seeing what you could do and what this person could do specifically here to try and help make this query run a bit faster. Okay, so let's talk about tuning distributed queries. So there's a couple of problems here, and let's imagine we've got a simple scenario. So we want to query across 3 databases. Let's imagine we live in some kind of microservices world where we've got all these little applications and they've all got a little database where they store their own data. And we've got these 3 databases, one which is storing all our invoice data, so presumably that's going to have a lot of rows in it. Hopefully, if you're successful in business, you've got lots of customers issuing lots of invoices. So that database or the tables in that database are going to have relatively large numbers of rows. Then we kind of got like a reference database, our countries, currencies, states, and so on. That's the main database that we're going to be connecting to in this example. So the tables there are going to be fairly small. You know, there's only a couple of hundred countries in the world and so on. So the tables are pretty small there. And then we've got an exchange rates database where we're storing information about what the exchange rates are from and to each currency. And now it's a bit unknown exactly how big this database might be, because maybe we've just got one row per currency and we just update that as the exchange rate changes. Or maybe we've got all the history, like daily, weekly, monthly exchange rate changes in there. So that could be any size, really. It could have a few rows, could have hundreds of thousands or millions. We're not really sure. You'd have to know more about your application and what's going on to be able to understand that. So those are our 3 databases. And as I say, I'm connecting to this countries database. And what I want to do is just produce a summary report. I want to get the total values for invoices in constant currency. So we could be generating invoices across multiple countries, and I need to convert them all into the same currency. So maybe we've got invoices in US dollars and euros and maybe pounds, who knows. We need to make them all the same. So that means we need to go and join all of these three databases in our query to get the result that I'm looking for. So this means we need to make a number of callouts. So if I connect to my countries and states, so first of all, the database can join those two tables together. Then it needs to go out to the invoices table. So we've got an invoice header. So we'll get that information, and then pass it back over the database link to the primary database to join that to the countries and states and so on. And then we need to do that again because we've also got the invoice details, the invoice lines table. So we've got two tables there. So we're actually going to repeat that process. We're going to make two trips out to the invoices database, and then we got another trip out to the exchange rates database. So we've got, we're connecting to one database, 5 tables, and we're going across 2 database links. Okay, so we want to make this query faster. So what's the first thing we do when we're trying to tune SQL queries? Well, we look at the execution plan. We see what it tells us. So what does the plan look like when we get for this query? We're going across multiple databases. And this is where things kind of get a little bit interesting. So we get a plan and it look maybe something a bit like this. And note, we've got these 3 remote operations. So exchange rates, invoices, invoice lines, all just say remote. So that's not very helpful, right? We don't know exactly what's going on here. Are we got full scanning those? Are we using an index? Which index are we using? Well, we don't know. It just says it's a remote database. Okay, so we've already got one problem, but there's another problem further over on the other side of the plan. So we look over in this buffers column. So this tells us how much work the query is doing, how many blocks are we accessing. And suspiciously, it seems like we're doing no work to get the information out of the exchange rates, invoices, and invoice lines, right? That just can't be right, because assuming the query actually returns data. So we are missing some information here. We can't see how we're accessing the tables, and we can't see how much work we did to access those tables. So this is one of the starting points for distributed queries. That's a problem. We're kind of stuck and we're not really sure what's going on. We can see some information. You know, we can see how many times we called out to the remote database. So we can see we went to exchange rates and invoices 60 odd times, and we did 700 odd calls to the invoice lines table. We can see how many rows they returned, but we don't know how much actual work, how many block gets. And this is one of the key things we want to look at to figure out whether we can improve the performance of this query. Okay, so how do we solve this? We got this plan and we're missing a whole bunch of information. So how do we get this information? How do we figure out what queries are going to be executed on the remote database, and how will we find out how much work they're doing? So this is kind of a 2-stage process. So the first thing that we're going to need to do is actually see what the query is that's executed on the remote database. So we can do something like this. So we'll get our plan, all stats last, and notice I've got this plus remote option. So that is going to give us information about what's going on over the database link. So I see a question come in from Kevin, what execution plan options we need to use to get buffers column. So you see this all stats option that I've got here in the query, in this statement, Kevin. That will give you the buffers information. So there's all stats or IO stats will both give you those details. I'm going to do a bit of a demo later as well. Well, I'll run through some more examples of how this works. So if you've got questions, you can come back to that at that point. Okay, so we've added this remote option when we're calling DBMS Xplan. So what does that show us, or how does that help us? Well, when we look at the plan, at the bottom of it, we'll get this information at the bottom. So we see we're selecting stuff from exchange rates, stuff from invoices, and stuff from invoice lines. So these are the queries that are executed on the remote database. So when you go to the other database, this is what you need to look for. You need to look for these queries to find out what their information is, to get their information from $, SQL, and so on. So we now found out what they are. We've gone to the remote database, and we're going to try and pull out that information from the execution plan stats. Now, here's where things get interesting again. Okay, so we know what the query is. but we try and get the information out. So we're running it again, we're getting all the stats about the plan, and we want information about the last execution. And we get a plan on the remote database that looks something like this. All we've got is some very basic information, some estimated rows, all that buffers and so on. That's just missing. Okay, that's not great. And we got a little note. It's saying gather plan stats. We need to use gather plan stats or set this parameter statistics level to all to capture this information. So as another key point, by default, the database doesn't capture this extended information about buffers and so on, about how much work the query is actually doing. You need to enable it either with this hint or by setting the statistics level to all. Okay, so we go through and we go, all right then, let's set the statistics level to all. So we run on our local database, the one that's got the countries and states and so on. We set the stats level to all, run our queries, then we go over to, let's say, the invoices database to see the information about what's actually happened, and we get the same query, we get the same thing again. It's like, okay, what's going on here? You know, we thought we'd enabled this extended information to find what the buffers are and what's going on, but nope, it's still missing. Okay, this isn't good. All right, so, okay, what do we need to do about this? Well, this alter session, we need to run that in the session on the remote database. So basically, we need to call this in our query. So we run it before running our query in our database, but we also need to run it in the database that the database link points to. And you can try and, this is where it gets a bit messy. You might think, well, how do we do this? How do we do an alter session across a database link? Well, the answer is kind of simple, although not necessarily obvious. You need to create a procedure on the remote database. So we'll call it set stats level, something like that, which just does the execute immediate. And then before you run the query, you have to set the stats level across the database link. Okay, so you have to enable the stats in your database and the remote database, and then get the plan using DBMS Xplan or whatever it is you want to do. So there are a number of steps that you need to go through to get the information about what's really going on with these remote queries, which kind of makes them quite fiddly and tricky to test and really see what's going on. Okay, so we've enabled this, we've run the query again, we're going to get some information about what that invoice lines query was doing. We're going to run it, get the plan again, and get the last execution, get a plan that looks a bit like this. So we're doing an index range scan, and you can see here it's got this buffers column, it says 6, that seems all right, right? You know, it's not doing a huge amount of work here. Okay, now, this is where things get even more interesting again. So if you may recall, with the plan we saw at the start, that was calling the invoices database 700 odd times to get this invoice information. So we don't need to, what that means, it ran this query 700 odd times. We don't want the execution, the information for the last execution, we want the cumulative total for those executions. So we want to sum up across all 700 of those and get how much work it did across all of them. So we do that by passing in the all parameter, and suddenly things don't look quite so rosy, right? We're doing, you know, there's a 700 odd starts and our buffer's 4,000 odd. We're doing a lot of work calling across the database link. And of course, we got the actual process of going across the network, which could be potentially quite slow, depending on where your database is and how good your networks are. So actually, we're doing quite a lot of work here. And how can we address this? What can we do to address this? All right, then. Any questions or comments on this before I move on to how we've kind of gone through how to diagnose the problem, how we can actually start resolving it? Any questions, comments? I see quite a few of you joined partway through. I'm going to do a little demo a bit later, which will kind of run through this again to show you kind of process to go through if you were going to do it yourself. So if you miss the start, not sure what's going on, it's okay. You'll get another chance to see what's happened. All right, so I'm not seeing any questions come in at the moment, so we'll move on. So we've looked at how to diagnose the problem. We've seen you get the plan from the local database, but you've also go out to got to go out to the remote databases, see what queries are run against those, and get the details for those plans as well. So it's a bit convoluted, a bit messy, but eventually you can pull it all together and see where the work's done and how much it is. So we figured out we're doing a lot of work, we're calling across these database and links a lot. How can we make this query faster? So key thing with any query, tuning any SQL query, is you need to minimize the number of resources it uses. So how many rows it actually processes, how many blocks it accesses, and so on. And when it comes to queries across database links, the really key thing you want to tune is how much work, how many times it's making calls across the network. So you want to really reduce down how many times you're going from, the local database to the remote ones, and how much traffic, how many rows you are sending over the wire. Because when it comes to database links, this could be a bit of an unknown. If you're lucky, the databases are both in the same data center with nice, super fast fiber connection between them. If you're unlucky, the other database could be, other side of the world in some other data center. Who knows? As soon as you've got this network involved, you're increasing the round trip time. So every time you make a call from your database to the remote one, the amount of time it takes to send the query to and from the database, that's going to start adding up very, very quickly, even when you've got a fast network. So that's the key thing we want to do here, is reduce how many times we're doing this, reduce how often we reach out to the remote database, and how much data we send back across it. So there are a number of techniques you can use to do this, and this is probably the only time I'm actually going to recommend that you do use hints in your query. So we're going to look at a couple of these. First up is the driving site hint. So what this does is it tells the database it tells Oracle which database owns the query. So when you're joining across database links, one of those databases owns the query, and all the joins happen on that database. So it kind of collects the information from the others and links it all together. The driving site tells the database who is the master, who does that joining, who collects the information from everyone else. So if we return to our example, we had our 3 databases that look like this. We were coming into our countries and currency states database like that. So by default, this is the master. This is the one that joins all the other data together. So it joins its own tables, then it's going to make a call out to the invoice database, get that information back, join that in, do that a couple of times, and it's got to make a call out to the exchange rate database, pull that information back out as well. Now, as I said, these invoices table likely to be large. They're probably going to be the largest ones in this set of queries that we've got here. So potentially we are sending a lot of data over the network here. So rather than do all the joining in the countries and states, it would be better to join the invoices tables locally and then pull in the country, states, and exchange rate information as appropriate. So rather than this database own it, we'd make the invoices database the master. So now saying to the Oracle, okay, we've come in connected to currencies, but kind of delegate control to invoices. So this will then join those two tables together, call out countries and states to get that information, and call out to the exchange rates to get that information, pull that all together. So now hopefully we are sending a lot less information over the wire. And when it's done all that, it's joined all the information together, it will then pass the result back to the database we originally connected to, countries one, and return that to the client. So this is helpful in a couple of scenarios. So first of all, as I said, if one of the databases has most of the data, tables with the most rows, it ensures we are sending the minimal amount of rows over the network. But also, each table that we add to the join is joined on whichever the master site is. So let's say we had actually 5 tables in our invoices family, maybe wanted payment information and whatever else in there as well. So if we connect countries and states, you need to call out to the invoices database at least 5 times, once for each table, probably more depending on the type of join you do and so on. So if we've got 5 tables in invoices, by making that a master, we ensure that we can join all of those locally, even though it's technically remote, and then only pull in the 2 or 3 other tables that we need to from the other databases. So this hint can be useful. It's particularly useful, as I say, if you've got one database, a remote database that has a large number of tables and only a couple of other tables locally or in various other ones. In that case, pushing one of them to be the master, really useful. Or it can be useful if one of the databases will have tables with significantly more rows than any of the others. Now, this is one where you've got to really know your application, your data, and so on, and it's maybe subject to change over time. So have a look at it, have a play, and it can help, but this may not help as much as you'd like it to. So that's the driving site. We're changing which host owns the database. Next thing we want to do is, well, so far I've said every time each new table that we're joining over a remote database means we're doing at least one extra call over the database link. It'd be kind of nice if we didn't have to do that, right? Why can't we just join all the tables in each database separately and then merge them all together? So for example, join invoices to invoice lines down here, countries to states over here, and exchange rates. Well, that doesn't have a join in this case, but whatever else is in here together, and then bring the 3 together as 3 separate units. And this is actually something you can do. Actually, a good way to help improve the performance is do all the joining at each remote database. So all the tables in each, whether that's local, database A, database B, make sure they are all joined as a unit if possible. Then send the data over the network to whichever is the driving site, whichever database actually owns the query. So do all the joining in the same place and then pass the results over. So how do we do this? Well, this probably relates to where we came in at the start for this question. The person was asking about the materialized hint to do this. Now, there's actually a better or a supported way of doing this, I should say. So rather than use the materialized hint, we can stick this no merge hint in here. So I've done it with the with clause with subquery factoring. You could do it with a regular inline view. For subquery factoring, it's just easier to see what's going on. But in either case, by adding this no merge hint in there, we're telling the database it has to join all these tables together before including any of the tables that we've got in the rest of our select statement. So by grouping together remote databases, it means that we are not combining them with local tables. So we join the 2 tables together, and then it will send the results back to us to the local database. So this is particularly useful. You know, you've got distributed query, several tables in each one. If possible, you can group them in their own subquery, no merge them so that they are joined as a unit, and then join the results together at whichever site happens to be the driving site. So if you were here at the start and we saw the query and where they're using the materialized hint, this is probably what they really want to do here. Use this no merge to tell the database that all of this has to happen together at the same time. So if we've got, as kind of general form of this, if you've got several database links, hopefully you haven't. I'm a bit scared and worried if you do. But if you do for some reason and have lots of database links to different databases, you can do a subquery for each one, no merge hinting them all together. So that means that we've got all the results from database 1, we join them together, all the results from database 2, join them together, database 3, join together, and so on, and then finally bring together the results those joins as a final thing. So hopefully that will involve sending a lot less information over the network. So hopefully that's a good technique you can use to help improve these joins over database links. Okay, so so far we've looked at how we can actually reduce how many calls we make out over the network, and we've seen like we can use the no merge hint, we can change the driving site. The best option by far is to just remove the network completely, right? Just cut it out the equation and have all the data locally. Now this is getting, how do we do this? Well, this is a bit more of a high level involved question and looks at, well, why on earth are you using database links? Why are you having to do this in the first place? Is this, some kind of data warehouse in disguise that you've got and you're doing a lot of these database queries over database links? If so, you're probably looking at some more of an involved like ETL process to actually pull that information out of the remote database to the local one to build your data warehouse out. Or maybe it's the database link queries are the process for building your ETL. That's the starting point for ETL. Or maybe it's just kind of a tactical solution just to help a little dashboard reporting, something like that. There's various reasons you can do. Building an ETL process is something that we just don't have time to discuss here, and there's loads of options to it. However, it's just, imagine this is kind of a tactical solution, something to help a particular query. We can cut the database link out by using materialized views. So materialized views are a great approach anyway to aggregate data down. So we've got, table with millions, billions of rows. We only want summaries by day. Build a materialized view, so we only have to scan a row per day rather than all the underlying data. Using materialized view to join the information over the database link and then get the data locally means that we cut the network out of the equation as well. This also gives us a lot of options in terms of indexing and so on materialized view. We can create local indexes here, do whatever performance twiddling that we want and feel like here. Key thing is we are now removing the network out of the equation, so we don't have to worry about latency there. We don't have to worry about how flooded the network is. Maybe it's lunchtime and everyone's busy Googling stuff and watching YouTube and your network's completely flooded with traffic. You don't need to worry about that because you've got all the information at the local database. So if this can be a good solution in some situations. Okay, so I was going to go on and show a demo, kind of walk through all the things we've just discussed and show them some more examples in a bit more detail. Any questions or comments before I start doing that? So I've got query, see we're querying invoices, states, currencies, exchange rates. Now, in order to do this demo, I've just kind of cheated. All tables are in the same database. I've created a database link that points back to itself. That's just to save me a whole bunch of hassle having to have different connections. However, it will show the principles. It will show the same kind of approach you need to take, what you need to do to actually diagnose these remote queries and things that you can do to improve them. So even though it's all the same database, actually, you could imagine that they were separate databases. Okay, so I've got my query here, and I'm just getting the total invoice value on a particular day. So we get one row back, and as always, we can get the execution plan with auto trace and SQL Developer, so this little F6 option, and that gives us, let's just shrink that down, kind of a big plan like that. So I'm not going to go into too much detail with that at the moment. That's not really what I want to show you. I just want to show you now, I've created these loopback database links, so it just points back to itself, but it still has to do a call over the network to actually get this information. So what happens when we get the execution plan now? So we do that, and it will take a little bit longer to run, and you will see the exchange rates and so on. We've now just got these lovely remote options. So what the heck is going on here? These full scans or the index scans? We don't know. We need to look up the query. Now, nice thing here is in SQL Developer, it's already given us what these remote queries are. So we can see for this one, it's looking up for exchange rates. For this one, it's looking up for invoices and so on. So you can kind of copy that text and then go to $SQL, just paste it all in. So this would now be running on the remote database, wherever that invoice database is. We'll get that out, we'll get the SQL ID, and that is what we're going to need to look for to get the execution plan. So now here, we run it in DBMS Xplan. So we're getting that SQL ID, that's that one pasted in there, and we're getting the IO stats from it for the last execution, run it, and this is where we get the lovely you know, sorry about that. Hint, you know, we've not got the information. You've not got the stats available. We haven't got the extended tracing information, so you can't get it. Okay. All right then. So how do we do that? Well, it suggests putting in the gather plan statistics hint. Okay. So we put that hint in and run the query again, and run it again. Well, we still get the, you know, you need to do this. Why? Well, the hint only enables tracing in the local database. So you still need to enable it in the remote database. And as I said, the way to do that is to create a procedure. So we're creating this procedure on the remote database, which is just doing the alter session, and then I'm going to call it. So this already exists, so I can just execute that. Now, when I run the query, take a second or so, we'll get the IO stats, and hopefully, yeah, there we go. It's all worked. So we can see that information. Excuse me. We can see how many rows it actually processed, how long it took, how many buffers it processed, and so on. So as I said, now this is looking all right. You know, one execution, we got 6 gets. Not perfect, but it's all right. If we go back to auto trace over here, and I shrink this down, if we look at how many times it calls over the network, so where's invoice lines, and we look for the starts column. Last start, 728 starts over here. We did that 728 times. We need stats from 728 calls. So we need to change that last to all. So run it again and pull the information over. Suddenly, everything's not looking quite so rosy. So we've got 4,000 odd gets that we're doing over here. Not so great. Okay, so we want to reduce these calls over the network. So what can we do? First up, I'll look at the driving site hint. Now, this is where things get interesting again. Okay, so if we run this query, I'll do the SQL developer auto trace. That will get us the execution plan, and run that, and we got nothing. All right, you know, it's literally coming back with no plan there. It's just hidden. Why is that? Well, all the information is in the other database. It's in the remote database. So we need to go over to that to get the stats about the query. Okay, and of course, if I'll just run it again, try it with the X plan, just to show it's not something SQL developers doing wrong. It will try and get the plan, but it will just tell us it can't get it, right? Because all the stats exist on the remote database. So what do? Well, you need to find the kind of transformed version of that query with all the quotes around it and so on. I'll save you the pain of that for now. I've dug that out originally. You know, here's something I did earlier. I got the SQL ID and we got the query, and you can see there's a lovely looking query like this with all the quotes. Not very obvious what's going on, but we have got the full plan. We've got everything that's actually going on here. And because we made the invoices database local and the master, the driving site, we've now got all the information about the invoices and the invoice lines. The database that's become remote now is the countries and currencies. Okay, so now that's the disappearing detail in our plan. So that's the driving site. That's one approach which can help. However, diagnosing again, getting the plan can be a bit tricksy. Okay, so that was one approach. Another technique we looked at, subquery factoring, or subquery factoring with the no merge hint. Now, if I just use the with clause and stick my invoices tables in that, and then select from the remote invoices doing the joins here, database doesn't join these as one unit by default. Okay, so it might still go across the database, link multiple times to do this. And if I shrink this down, we will see that that's in fact what it does. We've got 2 remote calls here, one for invoices, one for invoice lines. Not really what we wanted. We wanted to join those remotely, then get one set of results back, not 2. Okay, so how do we do that? Well, we need to put the no merge hint in there. And if we do that, I'll just pin this for a sec. We will see that we've now just got one remote call here, and in there it's got our query. Nice little way to see what's happened here. If you right-click and auto-trace, so if you've not been noticing, I've been pinning and unpinning these. There's this little pin, that means save it. If I run a new execution plan, it will start a new little window, new tab like this, and then we can compare them like this. And you can see that now, instead of 2 remote calls, we've just got the 1. So we've joined the invoices table together remotely and just got our 1 row back as a result. Brilliant. We're removing the network out of the equation here, or at least reducing how often we're actually calling it. So that has given us some good benefit. All right then, so we need to add that no merge hint in there. We get those stats, and final thing I want to mention as well, create materialized view. So here's one I made earlier. So this is the definition of it. It's going to call across the database link. So we have pulled all that information locally. We can then create our indexes, whatever we want on it, and we call that, and we get our little execution plan. And very good. Well, okay, exchange rates is still remote, but we've got all that information from our materialized view, making it much easier to get that information. Questions, comments, thoughts? Is this making sense to people? Do people find this? Are you finding this useful? Do many attendees actually write queries across database links regularly? Let me know. Just pop something in chat, and I'll say, because I'm curious. Because I know something I've done occasionally, but not a huge amount. Okay. We write for auditing. Okay. Could you, Amayan? Yeah, thanks, Kev. We write for auditing. Okay. If you could expand on that and say, give a bit more information, that would be useful. Amayan, or anyone else has got comments or questions on this, please let me know. Okay. If you're furiously typing away, don't worry about it. I'm just going to give a bit of a recap on what we've covered so far. So, tuning distributed queries. The very first challenge is just figuring out what the heck's going on. By default, when you get the plan, any stats or information about the remote database is basically missing. You just see that it is remote and which table you've accessed. So there's kind of process you need to go through. You need to get the SQL from the remote database, figure out what those queries are, go to the remote database, get the stats for them, and you have to enable the stats as well. As I said, alter the session by creating a procedure on the remote database and call that in your session. So that's the very first stumbling block when it comes to distributed queries, is just figuring out what actually is going on. It's just that extra hurdle which makes things a little bit more complicated to go through. Okay, I can see there's some more comments come in. Thanks, folks. All right then, so from Antonis, yes, we very often do remote queries for interface, and yes, it does sound very interesting. Kevin, 5 databases that have to communicate each other is very useful. Wow, okay, 5 databases, that sounds, so you'll be wanting to do that subquery factoring, the thing I said, query each one in its own little with clause with the no merchant, I think. That's interesting, cool. Okay, lots of people doing database links all the time. Okay, wow, a lot of people doing this. It's like, everyone's done them from a little bit, but good to see. Well, interesting to see that so many of you doing this so frequently. Okay, all right then. So getting back to where I was, as I said, very first stumbling block is just figuring out what's going on. Do remember one of the things I was saying, when you go to the remote database and get the stats, you have to use the all option to aggregate them all up together. If you've run the query on the source database, your starting database, multiple times, you'll actually collate them all together. Bit of a pain. If you're now, for me in testing, I was just doing a flush of my shared pool and so on before running it to make sure everything was clean. You probably don't have that option in your production databases, I'm sure. So it's worth doing a check before you run the query, what the stats are on the remote database, run your query, run it again, and then see how things have changed. So the all option by default will aggregate from all time that it's got in its cache, which could be multiple executions of that query. So good check is to see whether the start column in the plan matches the start from the remote database. So it will tell you how many times it did the call across the database link. Does that match the number shown in the remote database for how many times it was called? If they're completely different, then you need to do some like before and after capturing of snapshots to see what the difference is. So bear that in mind. Okay, so that's the first bit. You've got the information, you've figured out what's going on, you see where all the work's going. Well, what do you do about it? So there's various options. So first of those, again, these are probably the only time I will recommend that you do use hints. So that's the driving site. So if one of the databases is doing most of the work, make that the driving site if it is not the local database. So if you've got 2 or 3 database links in your query, and the majority of the tables or most of the data is in one of those databases, make that the driving site. This may not magically fix everything. It's not magically necessarily going to make everything faster, but hopefully it's going to reduce the number of times you're calling over the network and the amount of data you send over the network. So that can help in some situations. Something which is can help a lot more is the no merge subqueries. So do make all the joins local as much as possible. So group together the joins for the remote databases, put them in their own subquery with the no merge hint. So that means the Oracle will collect the information, do those joins on one database, and send the results over to whichever is the master. So good option, certainly if you've got a lot of tables in your query. You know, if each database has 5 or 6 tables, make sure you're joining them together, sending the results. Finally, materialized views. These are a good tuning option generally if you're aggregating large data sets, but particularly with database links, they can really help just avoid the network. You know, even if it's something simple like you're just querying a table remotely and you're not doing anything particularly fancy other than just running, you know, one table query goes over database link, well, you still got that network traffic back and forth, which can be expensive, as I said, particularly if you've not got the fastest network or the other database is somewhere in a separate data center, something like that. So by bringing that local, yes, you've got to think about keeping the materialized view up to date and in sync and so on, but you are eliminating completely possibly the biggest source of slowdown in your query. One of the things, so I've talked about using materialized views to kind of get rid of the database link. You could also use it just to aggregate the remote information. So in the queries, what I was doing was grouping the data up by day and state for the invoices, or you may be able to do that aggregation on the remote database, build a materialized view remotely, and then just pull over the aggregation information of the database link. Benefit there is, if you've got a lot of queries on the remote database which need that aggregate information, so doing totals by day, week, so on, it's all there for you, and those are benefiting as well. So we're only sending a smaller amount of network over the traffic over the network. We're sure we're joining everything in one database, and we just send the results. So best, or the fastest, is get the materialized view over the database link, but still building a remote materialized view and calling that over a database link could still actually benefit you quite a lot. So those are kind of the options, and we've recapped. So let's go back. So we started off, this all started off because of a question that came in. Someone wanted to tune a SQL query and wanted to make it a little bit faster. So this is the query that they had to start with, more or less. So as you can see, they were using a materialize hint to aggregate the data from a huge table, then join it to another table over a database link. I'm assuming this is the same database link. They've called it the same thing in their question. Presumably it's the same, maybe it's different. So, well, let's see. What would, based on what we've discussed, what would people suggest we do here? I'll show you what I was going to suggest in a minute. If you could just pop in chat what you think you would do to help improve it or change this query, let us know. Or is everyone feeling scared? Not sure about what to say. Small tables should be first. Could you expand on that, Litvin? So I'm assuming, based on the information, you have to allow remote DB doing all the work. Yeah. Use driving side hint. We could look at doing that. So we move all that information to the remote database. Bernhard, thank you. Yeah. So assuming these two database links are in fact to the same database, they've called the same, so presumably they are. Yes, we want that to ensure, to guarantee that those tables are joined together remotely, rather than sucking all this information over the database link to then go back over it again to get the small table information. So how are we going to do that? How are we going to do that? Well, here's what I was going to suggest to do. First up, take that get rid of that materialized hint, or change it to a no merge hint. As I said, materialize could work here, and in theory, this is the way it's supposed to work. Is it says take the results of this and store them in a local table. But as I said, undocumented, subject to change. So I'm not going to recommend that in this approach. I'd say make that a no merge, and then move these two tables to be joined remotely, so in the same subquery. So my first pass, based on knowing nothing more about this other than what you can see in this question, is I'd do something like this. Use no merge, join the two tables in the subquery, no merge. So now we're sure we're joining them remotely, and then we are only getting the aggregate information back across the database link. So hopefully, because the problem, there was some extra explanation. Seems that the problem was from time to time, if we pop back, occasionally these, rather than aggregating all this information and then joining to the small table, quite often it would join and then aggregate, which meant, checking a huge amount of data over the network to get a small amount result. Using the no merge within this should prevent that. If this isn't helping enough, okay, then I would look at materialized view. Okay, so what's the difference in no merge and driving site in such a query? So that's a good question, actually, do you live in? And in this instance, potentially it may not actually make much, it could be the same in that we are saying, assuming there are no other tables in this query, and this is the entire thing, potentially using the driving site, grouping these and doing the driving site should push those over there. Problem may come is if there's other tables in this query which we can't see, which is why I'd kind of say go down this approach first rather than driving site, because it's a bit more of a general technique rather than using driving site, which it's not always clear which the driving site should be. Does that help answer your question? Let's say if you're only accessing, if your query only accesses tables from one database over a database link, then actually the no merge and the driving site shouldn't really make much difference. They should come out pretty similar, but no merge hopefully is more, well, will be a bit more of a general approach, particularly if you've got more tables that you're going to be joining in here. Okay then, so that is, and as I said, I'd also, if this is not helping performance enough, I'd look at making this query a materialized view, either remotely or over the database link, because as they contend, this was returning few rows, so huge table was coming down to a few rows. I'd look at making a materialized view for that. All right then, so that's kind of all we had. We are, well, 10 to the hour, so got some time for some questions. If anyone's got any other comments, suggestions, let us know in the comments. Yes, so question or point, Materialized view may lead to data refresh issues. Very good point, Kevin. Yes, the thing you need to look for, if you've got it across the materialized view or using the materialized view, you need to look at how you're actually keeping that up to date. And we did have a session on materialized views a couple of months ago, I think it was, where we looked at kind of the ins and outs of refreshing them. But this is most useful if you're looking at historic data, which you know won't change. Because then once you've aggregated it in the materialized view, you've got insert only tables, it's never going to change, so you know that data is correct, you're always looking at the past. If the data updates regularly, or people need to go back and regularly make corrections to your data, then you've got to look at how and when you're refreshing it. You've got to get into the ins and outs of what refresh options are supported. If you can't do fast refresh on commit, how out of date are you willing, or can your users tolerate the data being stale before they'll complain and say it's wrong? That's where you've really got to work closely with your end users, figure out what their requirements are. As I said, we did have a separate session on that, so it's a whole topic in itself to discuss. Any other comments, questions, or suggestions before we wrap up? All right then, I'm not seeing anything else come in. If you're desperately typing, and don't worry about it, just put it on the website, we'll pick it up, and I'll follow up with you later. In the meantime, I hope you enjoyed this. More importantly, I hope you learned something. Thanks for joining me, and enjoy the rest of your day.